Hi guys, welcome once again to a new topic called inequalities. I've got a lot of requests from students to take session on inequalities, so that's the reason it was actually not a part of my plan, but it's actually a small area. There's only one big point which you need to understand. But then, since many of you asked to do this from the basics, I have made sure that I cover everything in this. Okay. So let's go ahead. Well, that's me. I'm Srinivas. I'm a mechanical engineer from IIT Dhanbad and an MBA from IIM Indore. I'm also the director of Career Launch Bangalore. I handle the areas of maths, logic, LRDI. I have been training students for the last 14 years. So that's my brief background. Right, let's move on. Now, what are we going to learn in this module? Very clearly, there are three things that I want you to learn. Firstly, we are going to start from the basics of inequalities. I'll make no assumptions that you know anything about inequalities. I will start as if you are a third grade or a fourth grade kid. So if you already know the basics, you can skip directly to the part that you want to see by looking at the content that I'm going to show, the table of content. So you can skip and go to that part. The second is I'm going to build the concepts with logic, and I will make sure that you don't have to mug things up. Meaning, I'm going to show you examples why certain rule is made, so that you at least will understand the rule and not just blindly by heart the rule. One of the most common mistakes that students do is you by heart a rule without knowing why it exists in the first place. So if I'm an examiner, I can make a question where this rule is not applicable. A small tweak, because every rule is based on a set of conditions, and if I tweak the conditions, your rule does not work anymore. Next, apply the concept. So all these concepts that we're going to build from the scratch, from the basic, we're going to apply that with questions that I frame then and there, and we will see how these rules are applicable when it comes to the context of questions. So this is what we're going to see in this particular module. Well, the output by the end of the module, my purpose is to make you solve questions like this. So for those of you who are new to inequalities, this might look very scary. Those of you who know the basics, it might not look so scary. Either way, the point is I will make sure that you solve questions of this nature by the end of this short 3 to 4 lesson module. Okay, so let's start off. So by the way, why are we doing this inequalities? Well, in terms of IPMAT, we had in 2019, there were 3 questions directly based on inequalities without any other function being asked. And there were 2 questions with logarithms involved or some other function involved. That's 5 questions using the concept of inequalities in 2019. In 2020, there is 1 direct question and 1 question with logarithms. Now remember, 19 was 60 questions in maths and 2020 was 30 questions in maths. So that's the reason the number of questions from inequalities went down in 2020, because the number of overall maths questions itself became half. Because of the pandemic, I hope you guys remember or at least realize that because of the pandemic, the exam time was cut down and also the number of questions therefore was cut down. Well, let's start off. So what is an inequality? Inequality is nothing but a comparison of 2 things. Very simple. It's a comparison of a left-hand side and a right-hand side. Right? Now, in between the left-hand side and right-hand side, there will be some symbols that are going to be put. There are typically 4 symbols that we will see. One of the 5th symbol, all of you know, the equality, equal to sign, all of you know. Apart from the equal to sign, there are 4 other symbols which we will use in inequality. The first one is this symbol, and it is basically called as greater than sign. I'm taking it very basic, guys. So if you know this, please skip. Lesser than sign, which basically represents lesser than. The next one is basically the lesser than or equal to. And the last one is greater than or equal to. Okay, so these are the 4 symbols we're going to use, and these are called as inequality symbols. Right? What are we supposed to look at in inequalities? What are the various operations that you have to be careful about? First of all, we need to understand what happens when things go from left hand side to right hand side. Okay, we need to understand what happens. Is it same as equal to, or is there something different from an equal to sign? I mean, we know what happens in an equation: left hand side to right hand side, or right hand side to left hand side. But in inequality also, is it the same, or is there something different? Next is multiplying or dividing. So all the things that you know about equal to, we are again trying to see that with respect to your inequality. What happens when I multiply my entire inequality with a constant, right? Or dividing the entire inequality with a constant. What happens to it? Then what about inversing on both sides? What happens if I take inverse of the numbers on both sides, and so on and so forth. So this is a list of things I have made over here, and I'll take you through each one of these things, and by the end of these you will understand the complete essence, nature of inequalities. So let's start with the first one: sending terms from one side to the other. So this is nothing different from an equation. Now if I have x plus y greater than or equal to 6, when I send something which is adding or subtracting, if you notice, I'm talking about addition and subtraction, it will go to the other side and do the opposite. It is same as an equation. There is no difference. Okay, so I will write x is greater than or equal to 6 minus y. Similarly, if I have 2x minus 3 is greater than or equal to y, then I will write 2x greater than or equal to y plus 3. So here there is no problem. So I'm using only greater than symbol, guys. It is same for lesser than, greater than, lesser than or equal to, all symbols. It doesn't matter which symbol you use. The taking from left hand side to right hand side, or right hand side to left hand side, provided it is addition or subtraction, then there is no problem. It's same as an equation. However, when you're dealing with multiplication and division, which is the second thing you're going to look at, multiplication and division, here there is a slight change. Now equal to, you know, if I write 2x into y is equal to 6, you will know that I will write 2x equal to 6 by y. Or similarly, if I write 2 into 3 is equal to 6, you will write 2 equal to 6 by 3. But in inequality, it is not so simple that you can straight away take everything to the right hand side. Actually it is simple, but one small point to keep in mind. So what is that? If you have 2x into, or let me take numerical examples to help you. 2 into minus 3, definitely this is less than 0, correct? It is negative 6. But if you send this negative value, which is multiplying, to the right hand side, then notice what happens if you keep it as it is. 0 by minus 3. And what do you get? You will end up getting 2 less than 0, which is wrong. Why is this wrong? Because the thing about inequality and sending a multiplication or division to the other side is, when a negative number is going, the sign should change. The sign should change. So if the sign changes, you will get 2 greater than 0, which is right. Similarly, if you have minus 2x is greater than y, then you will write x is less than minus y by 2. This is correct. Because when minus 2 is going to the right hand side, the sign will change. Always, this is a mistake you should never do. So when you send something to the other side, make sure that it is positive. Otherwise, if it is negative, if you know for sure it is negative, the sign has to change. Which brings us to an interesting point. What if I write x into y is greater than 5? Can I write x is greater than 5 by y directly? I can't. Why can't I write? Because I don't know the sign of y. If y is, this is only true if y is positive. If y is negative, then my answer will become x is less than 5 by y. So depending upon the sign of y, I will have the sign changing accordingly. So the point that you need to understand is, you can't take randomly a variable to the right hand side without knowing what is the nature of the variable. A number, you know, because if a number is there, you know it is positive or negative just by looking at it. But a variable can assume any number, and hence you do not know the nature of it unless you confirm the nature of it. Please don't send things to the right hand side. or the left hand side for that matter. Don't change the side, right? So that's about your multiplication and division. The next we are going to look about is earlier we saw sending terms from left hand to right hand side. Now we will try to see what happens when you are multiplying or dividing the entire inequality with a constant, which is actually a similar one as what we did last time, what we did for sending over terms. So if I take an inequality, if I have 2x is greater than 5, and if I want to multiply this entire thing with positive number, let's say 6, then no problem. The answer becomes 12x greater than 30. So if you are multiplying throughout with a positive number, no problem. Keep it as it is, just multiply. However, if you are multiplying with a negative number, 2x greater than 5, and you are supposed to multiply this with negative 6, then you will get negative 12x and negative 30, but when everything is getting multiplied with negative, the sign will change. So the thing to keep in mind is when you are multiplying or dividing also is the same rule. Multiplying or dividing on both sides with a positive, sign does not change. Multiplying or dividing on both sides with a negative number, the sign will change. Once again, the output of this, or the thing that you have to be careful about. So the output is that if I have 2x is greater than y, then I cannot write 2x square is greater than xy, or 2x cube is greater than x square y, because it depends on the sign of x. What am I multiplying on both sides with? You have to be a bit careful about it. Sometimes it will work, sometimes it will not work. For example, let's take a look at it. 2x is greater than y. Let us say x is 3 and y is 1. So it will work. Now when you're multiplying on both sides with x, it will still work. 2x square is greater than xy. It will be true because 2 into 9 is greater than 3 into 1. Correct. Right? What happens if I take your x equal to minus 3 and y equal to 1? Then I will write 2x is less than y. Correct? This is the correct one to start with. But when I multiply on both sides, what do I get? Here I will get 2x square less than xy, and this is wrong. Why is this wrong? Because if you notice, left hand side is 2 into 9, because negative into negative becomes positive. Whereas if I keep the sign as it is, it becomes minus 3 into 1, and this is wrong. Why is this wrong? Because you forgot to change the sign and you know that x is negative. But which be coming back to the basic point, unless you know what is x, don't blindly multiply on both sides, or don't blindly divide on both sides also. You can't cancel x. If you say x square is greater than x, you can't cancel x and say x is greater than 1 directly. Okay, because what is the meaning? If x is, this is one possibility. What if x is minus 3? This will also work, correct? X is equal to minus 3. This will also work. So you will get minus 3 whole square is greater than minus 3, which is correct. But when you're cancelling it out, you are basically saying that minus 3 is greater than 1, which is wrong. So multiplying or cancellation, don't do blindly. We will see how to solve these kind of questions. We'll worry about it a bit later. We'll come to that. All right. So that's about multiplying or dividing. This is the point to keep in mind. You can't blindly multiply or divide without knowing the sign of the variable. Lastly, for this introduction class, we're going to look at inversing on both sides. The remaining, we'll take it up in the next video. Inversing on both sides. What is the meaning of inverse? So if you know, if I write x equal to 5, then I know 1 by x equal to 1 by 5. Inverse of a number n is 1 by n. Inverse of a number n is 1 by n. Now in inequality, let us see, is it so simple or not? If I write 5 is greater than 2, and if I inverse the numbers, see what happens. 1 by 5 and 1 by 2. If I keep it as it is, you will notice that this is 0.2 and this is 0.5. Actually, this is wrong. So what happens here? When both sides are positive, when both sides are positive and you're inversing the numbers, the sign is supposed to change. The sign changes. All right. So if I have 10 is less than 20, then I will have to write 1 by 10 greater than 1 by 20, because this is 0.1 greater than 0.05. Right? So make sure that you inverse the sign. But remember, this is the case when both are positive. What happens when both are negative? Let's take a case and look at it. Minus 3 is greater than minus 6. Or let's make it easy, minus 10. Which means minus 1 by 3 will be compared to minus 1 by 10. Now what is it supposed to be? Once again, the sign has to change, because you'll notice that this is minus negative 0.33 bar and less than negative 0.1. So negative also, if both are positive or both are negative, the sign will change. Also understand that when you have variables x is greater than y, you have to make sure that both are of the same sign, either both positive or both negative. Then you can write 1 by x less than 1 by y. But now the final case, what if each one is of opposite sign? And this is a no-brainer. If I write 5 is greater than minus 2, then I will keep the sign the same, because it is not about the magnitude comparison anymore. Now left hand side is a positive number, right hand side is a negative number. So the sign will not change anymore. So here it's a bit tricky, inversing. You can't blindly follow with a single rule. The sign will change if both sides are same positives or same negatives. However, if both sides are opposite in sign, one is positive, one is negative, then the inequality symbol will not change, because the positive will always be greater than the negative side, whether you take the inverse or not. Because when you take the inverse, negative will still remain in negative. It will not change. That's the idea. So these are the points, and there are a lot more points we're going to cover in the next couple of videos before we go on to learn the tick and cross method, which is where our inequalities classes will culminate. Okay, so I hope you enjoyed the basics. Go through this once again and come prepared for the next session. Thank you and see you soon.